Next, I will state the central limit theorem for sample means and show its application. The central limit theorem for sample means states that for a relatively large sample size n from a population X with parameters μx and sigma x, the sample mean x bar is approximately normally distributed, and its parameters μx bar and sigma x bar can be related to μx and sigma x, regardless of the distribution of x. For normally distributed x, the sample doesn't have to be large. Symbolically, this statement can be written in the following way. Next, I will show an example of an application of the central limit theorem for sample means. Consider the following problem. According to a study, the time between taking a pain reliever and getting relief for a randomly selected patient has unknown distribution with a mean of 46 minutes and a standard deviation of 5.9 minutes. Find the probability that the average time between taking a pain reliever and getting relief for a sample of 36 randomly selected patients is between 45 and 48 minutes. The first thing you want to do when solving a problem like this is to introduce a proper notation. So let x be the time between taking a pain reliever and getting relief for a randomly selected patient. Then, according to the problem, x has unknown distribution with parameters mean of 46 minutes and standard deviation of 5.9 minutes. If we let x bar be the average time between taking a pain reliever and getting relief for a random sample of size 36, then x bar by the central limit theorem, and the reason it applies here because the sample size is greater than 30, will have a normal distribution with the parameters mu x bar equal to mu x, which is 46, and sigma x bar equal sigma x divided by square root of n, which is 5.9 divided by square root of 36, which is 0.9833. Now, the probability that the average time between taking a pain reliever and getting relief for a sample of 36 randomly selected patients is between 45 and 48 minutes can be expressed symbolically like this. And this is a simple question when the distribution of x bar is known and is normal with given parameters. So we can standardize the variable and use the z-table. Then the answer will be 0.8250, or we can use technology and then the answer will be 0.8244. And now we have a complete solution. I just stated the central limit theorem for sample means and showed its application.